Section 5.2 talks about the properties of the normal distribution. Here are our learning objectives for the day. So let's look at an example. Pulse rates of randomly selected males have a distribution with a mean of 70 beats per minute, and we're going to use the Greek letter mu, that looks like this, to denote a mean. The standard deviation of the distribution, which we denote as sigma, which is a Greek letter, is about 11 beats per minute. What can we consider? Can we consider this a normal distribution? Well, yes, we can, because it's naturally occurring data. And if so, let's draw our normal curve. So when we draw our normal curve, trying to get as good of a normal bellow shape as possible. Not my best work. Let's try again. Remembering that we use mu and sigma to denote the mean. So here we have our mean in the middle of 70. Now what I want to do is when I'm drawing a normal distribution, I want to include 3 standard deviations above and below the mean. And we'll see why we want to do this in a little bit. So if I go up 1 standard deviation, that's 70 plus 11, 81. If I go up 2 standard deviations, which should be more evenly spaced out, but you know, she tried, that would be 92. And then I can go up 3 standard deviations, which would be 103. We have to do the same thing below the mean. So I'm going to subtract 11. That would give me 59. Then I'm going to subtract another 11 for the second standard deviation, which gives me 48 beats per minute. Then I subtract a third standard deviation, that gives me 37. So when we're drawing a normal curve, our mean, represented by the Greek letter mu, goes in the middle, and then we need to include 3 standard deviations above the mean and 3 standard deviations below the mean. So here's our solution, right? Our Greek letter sigma means standard deviation, and the region between -1 sigma and +1 sigma represents the values within 1 standard deviation of the mean. If I look at the values between 48 and 92, this is all data within 2 standard deviations, positive or negative. We're going to use sigma. Sigma means 2 standard deviations of the mean, because it's 2 standard deviations below or above. So it's kind of like absolute value, but not quite. We have a rule to tell us how much data is located within the first, second, and third standard deviation, and that is the 68, 95, 99.7 rule. It's a good name to memorize it, but it's not very creative. This gives us the percent amount of data values that fall within the first, second, and standard deviation. So within our first standard deviation, we're going to have 68% of our data values. Within 2 standard deviations of our data, we're going to have 95% of our data values. And within 3 standard deviations of our data, we're going to have 99.7% of our data values. That's about all of it, but not everything, because we could have outliers. Friendly reminder that anything that's 2 standard deviations above or below the mean, that's what we consider outliers. Just as a friendly reminder. So we can use the 68, 95, 99.7 rule in order to solve some problems. So here's a refresher. 68% of data within 1 standard deviation, which we use to represent with sigma, 95% of data within 2 standard deviations, and 99.7% of data within 3 standard deviations. So let's draw a beautiful normal distribution and interpret the normal distribution using percentages. So tests that make up the verbal, critical reading, and mathematics SAT and GRE, LSAT, GMAT, I don't remember what that's for, are designed so that their scores are normally distributed with a mean of 500 and a standard deviation of 100. So why don't we go ahead and draw a normal distribution. We've got our mean in the center, which sometimes is represented with m, and our standard deviation, which is 100. So we're going to go 1, 2, 3 standard deviations above the mean. So that would give me 600, 700, 800. I love it when we're working with nice, easy numbers. And we need to go 3 standard deviations below the mean. So that's going to give me 400. If I go 2 standard deviations, I get 300. If I go 3 standard deviations, I get 200. So let's interpret this data using percentages. So within my first standard deviation, I know I have 68% of the data. So 68% of scores are between, do you guys know that shorthand for between? Sorry, I used to have to take so many notes in college, and I learned a little bit of shorthand. Scores are between 400 and 600. Next, let's take a look at within 2 standard deviations using the 68, 95, 99.7 rule. 95% of scores are between 300 and 700. And then last but not least, if we go out 3 standard deviations, 99.7, I've got 99.7% of scores are between 200 and 800.